graph this as well. You're going to graph this line as well, just to check, you see. So let's do that. We'll get back to the calculator and we'll graph this line. Do you guys agree with that? Yeah, do that right. Okay, on. So we'll leave this one up here. We'll go to y equals, and let's do 12x minus 9. And graph that as well. Look at that. I'll change my window a little bit so it's a little easier to see. Does that look like a tangent? Yeah, it kind of does, isn't it? So that's how you can kind of check, and you'll be able to know right away whether it's not right. There you go. There we go. And that should be 215, should be right there. There it is, see? So there's your check. And I'll just paste this as well. And there's your tangent line right there. Okay, so that checks out. Yes. Well, yeah, the question may ask you just for the slope of the tangent line. It may ask you for the equation of the tangent line at this point, x equals 2. The name of this point as well, if you run across this in the textbook, is the point of tangency. Tangency. Okay, it's the point of tangency. So if you see that wording in the textbook, that's what they're calling. So if they want the equation of the line at the point of tangency, you first of all have to find out the slope, and then use that point, the tangent point, to calculate an equation. Make sense? Okay. All right. Anybody have any questions at all? Right, what I usually do is I usually split up this exercise here. There's two formulas for finding slope. I'm going to get you to practice the one formula first. Then tomorrow I'll show you the second formula from this section. I'll get you to do the rest of the assignment. So we're going to do a couple more examples here together. I want to see how you guys are doing with doing something like this on your own, and then we'll go from there. So for your example here, do this one on your own, see if you can do it. Remember your formula. Here's the equation. It's actually, the f of x here, it's f of t, but that's okay. Because what's happening here, this is like a ball that's thrown into the air, and it makes this sort of parabolic function. And this t is time, okay? So f of x, f of t is the same thing. So use your slope limit formula for slope, and see if you can do that on your own. And if you have trouble getting started, that's kind of what it should look like in the start. Okay? And you can fill in the f of t, find out what f of 2 is, and so on. Factor, simplify, plug in your value. Go ahead. All right, so we went on with this question here, and it's a bit of a challenging question. And here's the work. Right here, you put in f of t minus f of 2, all over t minus 2. Now, factoring this was a little bit of an issue, so what we did was we wanted to get whole numbers, so we divided out a 0.1 to move the decimal place to the right, 1 point each. After doing synthetic division here, okay, to try and factor this, this is what we've ended up with, okay? And of course now we see that t minus 2 and t minus 2 will cancel out, so we don't have anything in the denominator, which is really good. And this is going to be, as t approaches 2, it's going to look like this, 0.1 times negative 49t plus 202. And now can we substitute t equals 2 in? Yeah, we sure can. So equals, now we're substituting in, you don't have to write the limit anymore. 49 times 2. 4 times 2, that's negative 98. Plus 202. So that's 104. Or 10.4. So the slope, 10.4. Does that check out? That's what your calculator says. Check my mental math there. Let's just see. Okay, that look good. Okay, and if you had some more information, the question like, if I gave you units, you would put units at the end there, but I won't worry about that. So that's using example or Formula 1. That's called Formula 1. Formula 1, and that's this one. The limit as x approaches a, f of x minus f of a all over x minus a. That is Formula 1 for finding slope of a tangent line given a function. Okay, slope of a line at a point on a function. Okay.